Hello all, myself Aishwarya Raikar. Today I am going to take the topic logic gates. So let's have an introduction to logic gates. Logic gates are nothing but what? Basic building blocks of digital circuit. What do? They perform the logic operation on one or more binary input. Now the output will be either low, low means 0, and high, high means 1. Now there are different types of logic gates. The very first category is basic logic gates, second is universal logic gates, third is derived logic gates. Under basic logic gates there are three. First is AND gate, then OR gate, then NOT gate. Under universal there are two gates, NAND and NOR. Under derived logic gates there are two, XOR and XNOR. Now the very first gate under basic logic gates is AND gate. Let's see AND gate. AND gate is used to perform the logical multiplication of the binary input, and it is a gate which accepts two or more than two inputs. Now what is the logic of AND gate? When all the inputs logic are 1, its output is 1. So this is the symbol of logic gates. And what is the Boolean equation for logic gate and logic gate? A dot B. So let's have a overview to the truth table. So as you can see here, A and B. For A 0011, for B 0101. What did I say? When all the inputs logic are 1, then only the output of this logic gate is 1. So here we can see 1 1 becomes 1, rest of the input combinations becomes 0. So the thing to be remember about AND gate is when all the inputs are 1, at that time only the output logic is 1. Next is OR gate. OR gate is again a most widely used logic circuit. Again it can have two or more inputs at a time. When all the inputs to the logic gate OR are low, then the logic is 0. So thing to be remember for OR gate is when the inputs to the OR gate are low, then only the logic output is 0. So what is the symbol? So this is the symbol for OR gate. And what is the Boolean equation for OR gate? Y is equals to A plus B. Y is equals to A plus B is the Boolean equation for the OR gate. This is the truth table. And what is the logic I said? When both the inputs are low, then only you will get the low output, else you will get the high output. Then NOT gate. NOT gate is one of the basic logic gates, and it is the only gate which has single input and single output. It is also known as what? Inverter, or I can say inverting buffer. When input signal is low, then the output signal is high, and when the input signal is high, the output will be low, as you can see here. So I can say A is equals to A bar. That is when A is 0, its output is 1, and when A is 1, its output is 0. So that was about the basic logic gates. Now let's come to the NAND gate. So NAND gate is a combination of AND plus NOT. And when it comes to the truth table of NAND, it is just exactly opposite of AND. Now just we discussed about AND gate. What did I say about NAND gate, AND gate? Let's come back to the AND gate. Here, what did I say? When all the inputs are 1, the output is 1. So it is exactly opposite to the AND gate. So here we can see, here what will happen? If both the logics are 1, then the output will be 0. That is exactly opposite of AND gate. So NAND is a exactly inverted operation of AND gate. That is the thing to be remembered about AND gate. And what is the Boolean equation? A dot B, the whole bar. Now the next gate is NOR gate. Similarly, the way NAND is a negation of AND gate, and NOR gate is a negation of OR gate. So what is the Boolean equation? A plus B the whole bar. And again, when it comes to the truth table, it is a complement of the OR gate. So as you can see here, in OR gate we discussed when both the inputs are low, you will get low output. Here it will be opposite. When both the inputs are low, then you will get high output, else the other combination will be 0. So these are about the universal logic gates. Now let's come to the derived logic gates. The very first derived gate we are going to discuss is XOR, which is called as exclusive OR. It is extensively used in arithmetic logic circuits, logic comparators, and error detection circuit. Again, it has two inputs and it gives one output. Now when we talk about XOR gate, the output of XOR gate is high. When it will be high? Only when its two inputs are dissimilar. That means if we provide same output to the XOR gate, then the output will be low. Only when both the inputs are different, that is 1 0 0 1, then only we will get high output. And what is the Boolean equation? A bar B plus AB bar. XNOR gate is a combination of XOR and NAND gate. So again, it is a complement of XOR gate. So when it comes to the truth table, it is the complement of XOR gate. So here is a truth table. This is the symbol of XNOR gate. And what is the Boolean equation? What is the Boolean equation? A bar B minus AB bar. Thank you.